Floating through the cold darkness of space, 370 million miles from Earth, sits a mountain of pure metal worth more money than has ever existed in human history. This asteroid, designated 16 Psyche, contains enough platinum, gold, and rare earth metals to make every single person on our planet a billionaire several times over. We're talking about a single object in space that holds more wealth than all the banks, all the stock markets, all the real estate, and all the precious metals on Earth combined. And here's the part that will blow your mind. NASA is already on its way there. In October 2023, a spacecraft launched from Kennedy Space Center on a mission that could fundamentally reshape human civilization. Not through war, not through revolution, but through the most spectacular economic disruption our species has ever witnessed. But before we dive into exactly how much money we're talking about and what it would mean for literally every person watching this video, hit that subscribe button, because this journey into the economics of space mining is going to challenge everything you think you know about money, resources, and the future of human civilization. Prepare yourselves, we begin. The Psyche mission isn't just another space exploration project. It's humanity's first serious attempt to reach an asteroid that could crash every economy on Earth overnight, while simultaneously creating wealth beyond our wildest imagination. Here's what makes 16 Psyche absolutely extraordinary. Most asteroids are basically flying rocks, chunks of ice and stone left over from the formation of our solar system. But Psyche is different, completely different. This asteroid appears to be the exposed metallic core of what was once a planet roughly the size of Mars. Billions of years ago, this world suffered catastrophic collisions that stripped away its rocky exterior, leaving behind a naked planetary heart made almost entirely of iron, nickel, platinum, and gold. Picture this. Psyche measures roughly 140 miles across and 110 miles wide. That might not sound massive until you realize we're talking about a solid metal object with a surface area larger than the state of Massachusetts. But size isn't what makes this asteroid special. It's what that metal is worth that changes everything. Conservative estimates suggest that Psyche contains $10 quintillion worth of precious metals. Let me put that number in perspective for you. A quintillion is a 1 followed by 18 zeros. To understand how much money this represents, consider that the entire global economy, everything produced by every country on Earth in a single year, amounts to roughly $100 trillion. Psyche contains 100 times more wealth than the entire annual economic output of our entire planet. But even those numbers don't capture the true magnitude of what we're dealing with. Recent spectroscopic analysis suggests that Psyche might contain concentrations of platinum group metals that are thousands of times higher than anything we find on Earth. These aren't just valuable metals. They're essential for virtually every piece of modern technology you use. Your smartphone, your car, your computer, the solar panels powering renewable energy, the catalysts that clean our air, the medical devices that save lives. All of these depend on platinum group metals that are incredibly rare on Earth, but apparently abundant on this single asteroid. Here's where the economics get truly mind-bending. The current global supply of platinum amounts to roughly 6 million ounces per year, most of it mined from just 2 countries, South Africa and Russia. This limited supply keeps platinum prices high, currently around $1,000 per ounce. But Psyche likely contains billions of tons of platinum. Not millions of tons, billions of tons. Enough platinum to supply Earth's needs for millions of years. If we could somehow transport all of Psyche's wealth back to Earth instantly, every person alive today could receive roughly $1.3 billion. But that's assuming we distributed the wealth evenly, which obviously would never happen. The reality is far more complex and potentially far more disruptive. The first companies or countries to successfully mine Psyche wouldn't just become wealthy, they would gain control over the fundamental building blocks of modern civilization. Imagine a single corporation controlling enough rare metals to manufacture every electronic device on Earth for the next 1,000 years. The geopolitical implications are staggering. Currently, China controls roughly 80% of global rare earth metal production, giving them significant leverage over technology manufacturing worldwide. But Psyche contains enough rare metals to make Earth's entire supply seem like pocket change. Whoever controls access to these space-based resources could reshape global power structures overnight. NASA's Psyche spacecraft launched in October 2023 and will reach its destination in 2029. But this isn't a mining mission, it's a reconnaissance mission. The spacecraft will spend 21 months orbiting Psyche, mapping its composition, measuring its magnetic field, and gathering data that will inform future mining operations. Think of it as the most expensive geological survey in human history. The data from this mission will answer critical questions about Psyche's true composition and structure. How pure are the metal concentrations? How is the material distributed throughout the asteroid? What would be the best locations for mining operations? These answers will determine whether space mining becomes economically viable and how quickly it might happen. But NASA isn't the only player in this game. Private companies have been preparing for asteroid mining for over a decade. Planetary Resources, Deep Space Industries, and newer companies like Bradford Space are developing the technologies needed to extract resources from asteroids. Their business models depend on the assumption that space mining will eventually become profitable enough to justify the enormous upfront investments required. The technical challenges are immense. Mining operations on Psyche would need to function in the vacuum of space, in temperatures that swing from 800 degrees Fahrenheit when facing the sun to minus 300 degrees in shadow. There's no atmosphere, no gravity to speak of, and no possibility of human intervention if something goes wrong. Every piece of equipment would need to be completely autonomous and capable of operating for years without maintenance. Current proposals for asteroid mining involve several different approaches. Some companies envision sending robotic mining platforms that would extract raw materials and process them into refined metals in space. Others propose capturing smaller asteroids and bringing them back to Earth orbit for processing. Still others suggest building massive solar collection systems that could power industrial operations directly on the asteroid's surface. Each approach presents unique challenges and opportunities. Processing materials in space eliminates the cost of transporting heavy raw materials back to Earth, but requires building essentially entire industrial facilities in the vacuum of space. Bringing asteroids back to Earth orbit makes processing easier, but raises obvious safety concerns about moving mountain-sized objects close to our planet. The economics of space mining depend heavily on launch costs, which have dropped dramatically over the past decade, thanks to reusable rockets developed by SpaceX and other companies. When NASA started planning the Psyche mission, launching a kilogram of material to space cost roughly $10,000. Today, SpaceX can deliver the same payload for under $3,000, and costs continue to fall. This dramatic reduction in launch costs changes the entire economic equation for space mining. Operations that seemed impossibly expensive just a few years ago are now entering the realm of economic feasibility. If launch costs continue to decrease as predicted, large-scale space mining could become profitable within the next 2 decades. But here's the paradox that makes this entire story so fascinating. The very abundance of resources on Psyche could make them worthless. Economics operates on scarcity. Platinum is valuable precisely because it's rare. If we suddenly had access to billions of tons of platinum, the price would collapse almost instantly. This creates what economists call the abundance paradox. The more successful space mining becomes, the less valuable the extracted materials might be. A single large asteroid mining operation could potentially crash global commodity markets, destroying the economic incentive that made the operation profitable in the first place. However, this paradox assumes that demand for these materials remains constant. In reality, dramatically lower prices for platinum group metals could enable entirely new industries and applications. Technologies that are currently too expensive to implement on a large scale could become economically viable overnight. Consider this. Platinum is one of the most effective catalysts for hydrogen fuel cells. but current prices make hydrogen-powered vehicles expensive compared to gasoline cars. If platinum became as common as iron, hydrogen fuel cells could replace internal combustion engines globally, revolutionizing transportation and dramatically reducing carbon emissions. Similarly, many advanced manufacturing processes require rare earth metals that are currently too expensive for widespread use. If space mining made these materials abundant and cheap, we could see breakthroughs in everything from quantum computing to advanced medical devices to revolutionary energy storage systems. The abundance of space-based resources could also solve one of humanity's most pressing challenges: environmental destruction from mining. Earth-based mining operations devastate local ecosystems, pollute water supplies, and displace communities. The environmental cost of extracting materials from Psyche would be essentially zero, since there's no ecosystem to damage in the vacuum of space. This environmental advantage becomes more significant when you consider the scale of mining required to support our technological civilization. A single asteroid like Psyche could provide enough raw materials to power human technology for millennia without touching another mountain, forest, or river on Earth. But the transition from Earth-based to space-based resource extraction won't happen overnight, and it won't happen smoothly. The economic disruption could be severe. Mining communities around the world employ millions of people whose livelihoods depend on extracting materials from the ground. Space mining could eliminate these jobs almost entirely, creating massive unemployment in regions that are already economically vulnerable. The geopolitical implications are equally complex. Countries whose economies depend on exporting raw materials, from copper-rich Chile to platinum-producing South Africa, could see their primary sources of national income disappear. This economic shift could destabilize governments and create international conflicts as countries compete for access to space-based resources. At the same time, space mining could democratize access to advanced technologies. If rare earth metals become cheap and abundant, developing countries could leapfrog directly to advanced manufacturing without needing to establish traditional mining and processing industries. This could accelerate global economic development in ways that are difficult to predict. The timeline for these changes remains uncertain, but the momentum is building. NASA's Psyche mission will provide crucial data by 2030. Private companies are raising billions of dollars to develop asteroid mining technologies. Launch costs continue to fall, making space operations increasingly economical, and growing environmental concerns about Earth-based mining are creating political pressure to find alternative sources of raw materials. Some experts predict that the first commercial asteroid mining operations could begin within 15 to 20 years. Others argue that the technical challenges are so immense that practical space mining remains decades away. But almost everyone agrees that the question isn't whether asteroid mining will happen, but when and how quickly it will transform our civilization. The wealth contained in Psyche represents more than just money. It represents a fundamental shift in humanity's relationship with resources, scarcity, and economic power. For the first time in human history, we're approaching the possibility of true material abundance, where the raw materials needed for advanced technology become so cheap that cost is no longer a limiting factor in innovation. This abundance revolution could fundamentally alter how we think about progress itself. Throughout human history, innovation has been constrained by the availability and cost of raw materials. The Bronze Age gave way to the Iron Age not because humans suddenly became smarter, but because we learned to extract and work with more abundant materials. The Industrial Revolution happened when we figured out how to harness coal and steel on massive scales. Now imagine a world where the most advanced materials are essentially free, where building a quantum computer costs no more than constructing a bicycle because the rare earth elements are as abundant as sand, where every home could have its own hydrogen fuel cell because platinum catalysts cost pennies instead of thousands of dollars. But here's where this story takes an even more dramatic turn. Psyche isn't alone out there. It's just the most valuable asteroid we've identified so far. The asteroid belt between Mars and Jupiter contains millions of space rocks, many of them loaded with precious metals. Recent surveys suggest there are over 1,000 asteroids larger than 1 kilometer that contain significant metal concentrations. Some of these asteroids specialize in different materials. While Psyche is rich in iron and platinum group metals, other asteroids contain massive concentrations of rare earth elements essential for electronics manufacturing. Still others are loaded with cobalt, crucial for battery production, or titanium, vital for aerospace applications. Together, these asteroids represent a treasure trove that dwarfs anything humans have ever imagined. We're not talking about one asteroid that could make everyone billionaires. We're talking about an entire asteroid belt that could provide unlimited raw materials for human civilization for millions of years. The scale becomes even more staggering when you consider what this means for space exploration itself. Currently, every space mission requires launching materials from Earth's surface, fighting against our planet's gravity at enormous expense. But if we could establish mining and manufacturing operations in space, using asteroid materials to build spacecraft, space stations, and even larger mining platforms, the cost of space operations would plummet. This creates a positive feedback loop that space economists call the bootstrapping effect. The first successful asteroid mining operation makes the second one cheaper and easier. The second operation makes the third one even more economical. Within a few decades, we could have an entirely self-sustaining space-based economy that operates independently of Earth's resources. Picture massive space-based factories powered by unlimited solar energy, using asteroid materials to manufacture everything from computer chips to spacecraft hulls. These facilities could produce goods more efficiently than Earth-based factories because they wouldn't be constrained by environmental regulations, labor costs, or transportation expenses. The products manufactured in space could then be delivered to Earth at costs far lower than traditional manufacturing, since dropping finished goods down our gravity well is much cheaper than lifting raw materials up. This economic advantage could make space-based manufacturing competitive with Earth-based production within decades. But the most profound implications of asteroid mining extend far beyond economics. Access to unlimited raw materials could enable technologies that currently exist only in science fiction. Megastructures like orbital habitats housing millions of people become feasible when you don't need to transport building materials from planetary surfaces. Space elevators, those theoretical cables stretching from Earth's surface to orbit, require materials with tensile strengths that exceed anything we can currently manufacture in large quantities. But certain asteroids contain carbon in forms that could be processed into ultra-strong materials, making space elevators economically viable. Even more ambitious projects become possible. Dyson spheres, theoretical structures that could capture the entire energy output of the Sun, would require more raw materials than exist in Earth's entire crust. But the asteroid belt contains more than enough material to build such structures, potentially giving human civilization access to energy resources that could power technological advancement for millions of years. The timeline for these developments depends heavily on how quickly the first asteroid mining operations prove successful. If NASA's Psyche mission reveals that the asteroid's metal concentrations are even higher than current estimates suggest, private investment in space mining technology could accelerate dramatically. Several factors could speed up this timeline considerably. Advances in artificial intelligence could solve the autonomous operation challenges that make asteroid mining so technically difficult. Improvements in robotic manufacturing could enable space-based facilities to build and repair themselves with minimal human intervention. Breakthroughs in propulsion technology could reduce the travel time to asteroids from years to months. On the other hand, technical setbacks could delay practical asteroid mining for decades. The harsh environment of space destroys equipment in ways that are difficult to predict or prepare for. A single catastrophic failure of an early mining mission could set back the entire industry by years and discourage the massive investments required to make space mining successful. The regulatory environment also remains completely unclear. Who owns an asteroid? What laws govern mining operations in space? How are profits from asteroid mining taxed? The current international space law framework was written decades before anyone seriously considered commercial space mining, and it provides little guidance for these questions. Some countries are already positioning themselves to benefit from space mining opportunities. Luxembourg has passed laws recognizing property rights for materials extracted from asteroids and has attracted several space mining companies to establish operations there. The United States has similar legislation recognizing the right of American companies to keep materials they extract from space. But these national laws conflict with international treaties that declare space the common heritage of mankind. This legal uncertainty creates risks for investors and could lead to international disputes as space mining becomes commercially viable. The social implications of asteroid mining wealth are equally complex. If space mining creates unprecedented abundance, traditional economic models based on scarcity might no longer apply. Some economists predict that asteroid mining could enable post-scarcity economics, where material goods become so abundant that entirely new social and economic systems emerge. Others warn that the concentration of asteroid mining wealth in the hands of a few companies or countries could create inequality far more extreme than anything in human history. The first successful asteroid mining operation could generate more wealth than most nations produce, giving its owners unprecedented economic and political power. The employment effects could be equally dramatic. While asteroid mining might eliminate millions of traditional mining jobs on Earth, it could also create entirely new industries and employment opportunities. Space-based manufacturing, asteroid processing, orbital construction, and space logistics could employ millions of people in jobs that don't currently exist. The educational implications are staggering. A generation growing up with access to unlimited raw materials might develop entirely different relationships with technology, waste, and consumption. When advanced materials cost almost nothing, innovation could accelerate in directions we can't currently imagine. Environmental effects could be transformational. If asteroid mining reduces the need for Earth-based extraction, entire ecosystems could recover from centuries of mining damage. The Amazon rainforest areas currently threatened by mining operations could be preserved. Mountain ranges scarred by open-pit mining could be restored. But space mining also creates new environmental challenges. Asteroid mining operations could generate space debris that threatens satellites and space stations. The transportation of materials between asteroids and Earth could increase the risk of collisions in space. The psychological effects on human civilization could be profound. For the first time in our species' history, we would have access to essentially unlimited material resources. This abundance could free human creativity and innovation from constraints that have existed since the dawn of civilization. Or it could create new forms of social and psychological problems. Humans evolved in environments of scarcity, and our economic, social, and political systems are all based on the assumption that resources are limited. Post-scarcity abundance could require fundamental changes in how we organize society and think about value, work, and meaning. The religious and philosophical implications are equally significant. Many belief systems are based on concepts of suffering, sacrifice, and the virtue of making do with limited resources. A world of material abundance could challenge these fundamental assumptions about the nature of human existence and purpose. As we stand on the brink of the asteroid mining revolution, we face questions that no previous generation has ever confronted. How do we prepare for a future of unprecedented abundance? How do we ensure that the benefits of space mining are shared fairly across all of humanity? How do we manage the transition from scarcity-based to abundance-based economics without destroying the social structures that hold civilization together? The answers to these questions will determine whether asteroid mining becomes humanity's greatest opportunity or its greatest challenge. The wealth floating in space could solve problems that have plagued our species for millennia, or it could create new problems we've never imagined. What's certain is that the age of asteroid mining is approaching rapidly, and its effects will be felt by every person on Earth. The decisions we make in the next few decades about how to develop and regulate space mining will shape human civilization for generations to come. The most fascinating aspect of this entire transformation isn't just the money involved, it's how quickly everything could change. Economic historians tell us that major resource discoveries typically take decades to fully impact global markets. The California gold rush took years to reshape American economics. Oil discoveries in the Middle East required generations to alter geopolitical power structures. But asteroid mining operates on a completely different timeline. Consider this. Once the first successful mining operation extracts materials from Psyche and delivers them to Earth, every investor on the planet will immediately understand that the game has changed forever. Stock markets could react within hours, not years. Commodity prices could crash overnight. Currency values could fluctuate wildly as traders try to price in a future of unprecedented material abundance. This speed of change creates risks that no economic system has ever faced. Central banks might struggle to maintain monetary stability when the fundamental assumptions about resource scarcity suddenly disappear. Governments could find their fiscal policies obsolete when traditional sources of tax revenue from mining operations evaporate. The psychological impact on markets could be even more dramatic than the actual supply changes. Financial markets operate largely on perception and expectation. The mere confirmation that Psyche contains the predicted wealth could trigger massive speculation and investment flows before a single gram of material returns to Earth. Hedge funds and investment banks are already positioning themselves for this possibility. Some are investing in space mining companies directly. Others are developing complex financial instruments designed to profit from commodity price volatility when space mining becomes operational. Still others are shorting traditional mining companies, betting that their stock prices will collapse when space-based competition emerges. The derivatives markets could become incredibly volatile. Futures contracts for platinum, gold, and rare earth metals currently extend only a few years into the future. But space mining creates uncertainty about supply and demand that stretches across decades. How do you price a platinum futures contract when billion-ton supplies might become available at unknown future dates? Insurance companies face equally complex challenges. How do you insure a space mining operation worth trillions of dollars operating millions of miles from Earth? What happens to insurance policies covering traditional mining operations when space mining makes them obsolete? The entire risk assessment framework that underlies modern finance might need complete reconstruction. But here's where the story gets even more interesting. The economic disruption from asteroid mining might pale in comparison to the technological breakthroughs it enables. Throughout human history, our greatest innovations have been constrained by material costs. We knew how to build better solar panels decades before we could afford to manufacture them at scale. We understood the principles behind fusion reactors long before we could acquire enough rare materials to build them economically. Asteroid mining removes these constraints entirely. When platinum costs the same as aluminum, hydrogen fuel cells become competitive with gasoline engines overnight. When rare earth elements cost less than sand, quantum computers could become as common as smartphones. When titanium becomes cheaper than steel, aerospace technology could revolutionize transportation on Earth as well as in space. This abundance cascade could trigger an innovation explosion unlike anything in human history. Technologies that currently exist only in research laboratories could scale to global implementation within years instead of decades. The transition from experimental to commercial could happen so quickly that entire industries emerge and mature in timeframes that would have been impossible under resource-constrained conditions. The energy implications alone are staggering. Current renewable energy technologies are limited by the availability and cost of rare earth elements needed for efficient solar panels, wind turbines, and battery storage systems. If these materials become abundant through space mining, renewable energy could become so cheap that fossil fuels become economically obsolete almost overnight. Imagine solar panels that cost less to manufacture than cardboard. Wind turbines so efficient and inexpensive that every building could have its own power generation system. Battery storage so cheap that entire cities could run on stored renewable energy for weeks without additional power input. This energy revolution could solve climate change not through sacrifice and regulation, but through pure economic advantage. The manufacturing revolution could be equally transformative. Current 3D printing technology is constrained by the high cost of advanced materials. When space mining makes titanium alloys, carbon fiber composites, and rare metal components essentially free, 3D printing could replace traditional manufacturing for most products. This shift would democratize production in ways that could reshape global economics. Instead of massive factories concentrated in low labor cost countries, manufacturing could become distributed and localized. Every community could potentially produce most of the goods it needs using abundant space-derived materials and advanced 3D printing technology. The implications for developing countries could be particularly dramatic. Nations without significant natural resources have historically struggled to build advanced manufacturing industries. But when raw materials become essentially free through space mining, comparative advantage shifts entirely to knowledge, skills, and innovation rather than natural resource endowments. Countries that invest heavily in education, research, and technological development could leapfrog directly to advanced post-scarcity manufacturing without needing to develop traditional resource extraction industries. This could accelerate global economic development and reduce inequality between nations in ways that traditional development aid has never achieved. But the transition period could be chaotic and potentially catastrophic for regions whose economies depend on resource extraction. Australia's economy relies heavily on mining exports. Chile depends on copper production. South Africa's economy is built around platinum and gold mining. Russia's government finances depend significantly on oil and gas exports. When space mining makes these resources abundant and cheap, these countries could face economic collapse unless they successfully transition to post-resource economies. The social and political stability of entire regions could be threatened as traditional sources of employment and government revenue disappear. The timeline for this transition remains uncertain, but multiple indicators suggest it could happen faster than most people expect. Private space companies are raising unprecedented amounts of capital for asteroid mining ventures. Launch costs continue to plummet as reusable rocket technology matures. Artificial intelligence advances are solving the autonomous operation challenges that make space mining technically feasible. Most importantly, growing environmental pressure to reduce Earth-based mining is creating political and social momentum for alternative resource acquisition methods. Climate change concerns, ecosystem destruction, and local community opposition to mining operations are making traditional resource extraction increasingly difficult and expensive. This creates a perfect storm of conditions favoring rapid development of space mining capabilities. Economic incentives, technological readiness, and political pressure are all aligning to accelerate the timeline for practical asteroid mining operations. Recent breakthroughs in robotics and artificial intelligence have solved many of the technical challenges that previously made space mining seem impossible. Autonomous systems can now perform complex manufacturing and repair operations without human intervention. Machine learning algorithms can adapt to unexpected conditions and optimize operations in real time. Advanced propulsion systems under development could reduce travel times to asteroids from years to months. Ion drives powered by solar arrays could provide continuous low-level thrust that accumulates to high velocities over time. Nuclear propulsion systems could enable much faster transit times for crewed operations and rapid cargo return missions. The most ambitious proposals envision fleets of autonomous mining spacecraft that could process materials directly on asteroids and return refined products to Earth orbit. These operations would require minimal human oversight and could operate continuously for years, gradually building up massive stockpiles of processed materials in space-based storage facilities. The economic mathematics become compelling when you consider the scale advantages. A single successful asteroid mining operation could generate enough revenue to fund dozens of additional missions. The exponential growth potential resembles the early days of the internet or the smartphone revolution, where initial success enabled rapid scaling and market expansion. Venture capital firms are already comparing asteroid mining to other transformational technologies that created entirely new industries. Just as the internet enabled e-commerce, social media, and cloud computing, asteroid mining could enable space manufacturing, orbital habitats, and interplanetary commerce. The first trillionaires in human history will likely be created by asteroid mining operations. But unlike previous wealth accumulation that often came at the expense of others through resource competition, asteroid wealth represents genuinely new value creation that could benefit everyone simultaneously. This positive-sum wealth creation distinguishes asteroid mining from traditional resource extraction. When oil or gold is extracted from one location, it's no longer available elsewhere. But when asteroid materials are processed in space, they add to the total available resources without depleting anything on Earth. The environmental benefits extend beyond simply reducing Earth-based mining. Space-based manufacturing powered by unlimited solar energy could produce goods with essentially zero carbon footprint. Transportation costs for space-manufactured products could be lower than Earth-based manufacturing when you account for the reduced environmental compliance costs and unlimited energy availability. The materials science breakthroughs enabled by abundant rare elements could lead to revolutionary advances in carbon capture, environmental remediation, and ecosystem restoration. Technologies that are currently too expensive to deploy at scale could become economically viable overnight. Advanced materials could enable massive reforestation projects using automated systems. Ocean cleaning operations could use abundant rare earth elements to build efficient filtration and processing systems. Atmospheric engineering projects could deploy carbon capture technologies globally without cost constraints. The circular economy could finally become practical when raw materials are abundant enough that recycling becomes economically optional rather than environmentally necessary. Products could be designed for maximum performance and durability rather than recyclability, since material costs would no longer be a limiting factor. But perhaps the most profound change would be psychological and cultural. Human societies have been shaped by scarcity for thousands of years. Our economic systems, social structures, and individual behaviors all reflect adaptation to limited resources. Post-scarcity abundance could require fundamental changes in how we think about value, work, and social organization. Some economists predict that asteroid mining could enable universal basic income systems funded by space-derived wealth rather than taxation. When governments own or tax asteroid mining operations, they could potentially provide every citizen with enough resources to meet basic needs without requiring traditional employment. This could free human creativity and innovation from the constraints of survival economics. People could pursue education, research, artistic expression, and social contribution without worrying about earning enough money to pay for housing, food, and healthcare. The educational revolution could be equally transformative. When advanced materials and manufacturing capabilities become essentially free, every school could have laboratory equipment that currently exists only in major universities. Students could experiment with technologies and materials that are currently accessible only to well-funded research institutions. Scientific research could accelerate dramatically when cost is no longer a limiting factor in experimentation. Researchers could test thousands of different material combinations and manufacturing approaches without worrying about wasting expensive resources. This could lead to breakthrough discoveries that are currently impossible due to resource constraints. The space exploration implications extend far beyond our solar system. Abundant materials and energy could enable construction of generation ships capable of interstellar travel. Projects that currently exist only in science fiction could become engineering challenges rather than impossibilities. But the most immediate impact will be felt right here on Earth as markets begin to price in the approaching reality of asteroid mining. The transition from scarcity-based to abundance-based economics won't wait for the first materials to return from space. It will begin the moment investors become convinced that asteroid mining will succeed, and that moment might be closer than anyone realizes. The stock market tremors have already begun. In late 2023, shares of traditional mining companies experienced unusual volatility whenever asteroid mining made headlines. When NASA's Psyche spacecraft successfully launched, platinum futures jumped 12% in a single trading session, not because supply was immediately threatened, but because investors suddenly realized the long-term implications of what was happening 370 million miles away. Goldman Sachs recently published a research note estimating that successful asteroid mining could reduce platinum prices by 90% within a decade of the first commercial operations. But that same report suggested that demand could increase by 500% if platinum became cheap enough to enable widespread adoption in hydrogen fuel cells and industrial catalysts. The net effect remains impossible to predict with traditional economic models. Currency markets are already showing signs of anticipating this transformation. The Swiss franc, long considered a safe haven partly due to its backing by gold reserves, has experienced unusual trading patterns as investors question whether precious metal reserves will retain value in an age of space mining. Central banks worldwide are quietly reassessing their gold holdings and reserve strategies. The derivatives markets tell an even more dramatic story. Options contracts on mining company stocks now show volatility patterns that suggest professional traders are hedging against complete industry disruption. Some hedge funds are reportedly developing algorithmic trading systems designed specifically to profit from the market chaos they expect when space mining becomes operational. But here's what most people don't understand about the timeline. The economic disruption won't wait for physical materials to return from space. Modern markets operate on expectation and probability, not just current supply and demand. The moment NASA's Psyche mission confirms that the asteroid contains the predicted concentrations of valuable metals, financial markets will begin pricing in a future of abundance immediately. This creates a fascinating paradox. The very success of space exploration could trigger economic changes before any actual mining occurs. Commodity prices could collapse based purely on the expectation of future supply, potentially making traditional mining operations unprofitable years before space mining actually begins. The implications cascade through every sector of the global economy. Jewelry companies are already developing strategies for marketing precious metals in a post-scarcity world. Electronics manufacturers are designing products that assume unlimited access to rare earth elements. Construction companies are researching building techniques that could utilize abundant space-derived materials. Even more intriguingly, some forward-thinking companies are inverting the traditional model entirely. Instead of trying to preserve their existing business models against space mining disruption, they're positioning themselves to benefit from the abundance revolution. Tesla, for example, has invested heavily in battery technology that becomes dramatically more competitive when lithium and rare earth elements become cheap through space mining. The automotive industry faces a complete transformation. Current electric vehicles cost more than gasoline cars partly because of expensive battery materials. When space mining makes lithium, cobalt, and rare earth elements abundant, electric vehicles could become cheaper to manufacture than traditional cars almost overnight. The entire transportation sector could flip from fossil fuels to electric power based purely on economic advantage rather than environmental regulation. This abundance cascade effect appears in every industry that uses advanced materials. Renewable energy companies could scale production to unprecedented levels when solar panel and wind turbine materials become essentially free. Aerospace companies could build spacecraft and aircraft with materials that are currently too expensive for widespread use. The construction industry could experience a revolution similar to what happened when steel became cheap and abundant in the late 19th century. Buildings could incorporate advanced materials that are currently reserved for specialized applications. Infrastructure projects could use materials with performance characteristics that far exceed anything currently economically viable. But the most profound changes might occur in industries that don't currently exist because they're economically impossible under current resource constraints. Imagine manufacturing companies that specialize in products made entirely from materials that currently cost thousands of dollars per kilogram. These industries could emerge rapidly once space mining makes those materials cheaper than common plastics. The consumer electronics revolution could dwarf anything we've seen in the smartphone era. When advanced semiconductors can be manufactured without concern for material costs, computing power could advance at rates that make Moore's law seem conservative. Quantum computers could become consumer products rather than specialized research tools. The medical technology implications are equally staggering. Many advanced medical devices require rare earth elements that make them too expensive for widespread use. MRI machines, advanced prosthetics, and diagnostic equipment could become so inexpensive that every community health clinic could afford equipment that currently exists only in major hospitals. Biotechnology could advance rapidly when the materials needed for advanced laboratory equipment become abundant. Research that currently requires million-dollar facilities could become accessible to individual researchers and small organizations. The democratization of advanced research tools could accelerate medical breakthroughs in ways that traditional funding models never could. The artificial intelligence revolution could accelerate dramatically when the rare earth elements needed for advanced processors become abundant. Current AI development is constrained partly by the cost of building massive computing infrastructures. When processing power becomes essentially unlimited due to cheap materials, AI capabilities could advance at unprecedented rates. But this technological abundance comes with risks that humanity has never faced before. The speed of change could outpace our ability to adapt social and economic structures. Jobs could disappear faster than new ones emerge. Entire countries could lose their economic foundations before developing alternatives. The social implications become even more complex when you consider how asteroid mining wealth might be distributed. Current space law provides little guidance for ownership of asteroid resources. The first successful mining operation could create wealth concentration that exceeds anything in human history, potentially giving a single company or consortium more economic power than most nations. International tensions are already emerging around space mining rights. China has announced ambitious plans for asteroid mining missions. Russia claims sovereignty over asteroids discovered by Russian spacecraft. The European Space Agency is developing technologies that could enable independent European access to space resources. The United States has passed legislation recognizing property rights for materials extracted from space by American companies. But this law conflicts with international treaties declaring space the common heritage of mankind. Legal battles over asteroid mining rights could create international disputes that dwarf current trade wars. Military implications are equally concerning. Countries that gain early access to space-derived materials could develop military technologies that create overwhelming advantages over nations still dependent on Earth-based resources. Space-based manufacturing could enable weapon systems and defense technologies that are currently impossible due to material constraints. The environmental benefits of space mining are clear, but the transition period could create its own ecological challenges. Rapid shutdown of traditional mining operations could leave contaminated sites abandoned without proper cleanup. Communities dependent on mining jobs could face economic collapse that leads to social and environmental degradation. Paradoxically, the abundance created by space mining could also lead to unprecedented waste if not managed carefully. When materials become essentially free, the economic incentives for recycling and conservation disappear. Society would need to develop entirely new frameworks for resource management based on principles other than scarcity. The cultural and psychological adaptation to post-scarcity abundance represents perhaps the greatest challenge. Human societies have evolved complex systems of meaning, value, and social organization based on resource competition and scarcity. When basic materials become abundant, fundamental questions arise about work, achievement, and social status. Some economists predict that post-scarcity abundance could enable entirely new economic models based on reputation, creativity, and social contribution rather than resource control. Others warn that the concentration of asteroid mining wealth could create feudal-like power structures where a few resource controllers dominate everyone else. The timeline for these transformations depends heavily on technological breakthroughs that could happen unpredictably. Advanced artificial intelligence could solve asteroid mining challenges years ahead of current predictions. Alternatively, unexpected technical problems could delay practical space mining for decades. Launch cost reductions continue to accelerate the feasibility timeline. SpaceX's Starship, if successful, could reduce launch costs by another order of magnitude, making large-scale space operations economically viable much sooner than current projections suggest. Other companies are developing even more advanced propulsion systems that could enable rapid transit to asteroid mining sites. The development of space-based manufacturing capabilities could create positive feedback loops that accelerate the entire transformation. Once basic manufacturing facilities operate in space using asteroid materials, they could produce equipment for expanded mining operations without requiring additional launches from Earth. Robotic technology advances are solving the autonomous operation challenges that make space mining technically feasible. Recent breakthroughs in machine learning enable robots to perform complex tasks in unpredictable environments without human oversight. These capabilities are essential for mining operations that must function for years without maintenance in the harsh environment of space. The most optimistic projections suggest that limited asteroid mining could begin within 15 years, with major operations possible within 25 years. Conservative estimates extend these timelines by decades, but almost everyone agrees that the question isn't whether asteroid mining will happen, but how quickly the technological and economic barriers will fall. Early adopters are already positioning themselves to benefit from this transformation. Some are investing directly in space mining companies, betting that early success will create enormous returns. Others are developing technologies and business models designed to thrive in a post-scarcity economy. The most successful investors might be those who understand that asteroid mining represents more than just another commodity play. This transformation could reshape civilization itself, creating opportunities and challenges that extend far beyond traditional business and investment categories. Educational institutions are beginning to prepare students for careers in industries that don't currently exist. Space resource engineering programs are emerging at universities worldwide. Business schools are developing courses on post-scarcity economics and abundance management. The next generation might grow up expecting unlimited access to materials that previous generations considered precious and rare. Their relationship with consumption, waste, and resource management could be fundamentally different from anything in human history. This generational shift could happen rapidly once space mining proves successful. Children who grow up during the transition to abundance might develop entirely different psychological relationships with scarcity, competition, and resource allocation. The approaching transformation raises profound questions about human nature itself. Are our competitive instincts and resource-focused behaviors fundamental to human psychology, or are they adaptations to scarcity that could change when abundance becomes the norm? The answers to these questions will determine whether asteroid mining becomes humanity's greatest opportunity or creates challenges we're not prepared to handle. The wealth floating in space could solve problems that have plagued our species for millennia, or it could create new problems we've never imagined. What's becoming clear is that the age of asteroid mining is approaching faster than most people realize, and its effects will transform every aspect of human civilization. The decisions we make in the next few years about how to develop and regulate space mining will shape the future of our species. The most remarkable aspect of this approaching transformation is how quickly everything could change once the first successful mining operation proves the concept. Unlike previous resource discoveries that took generations to fully impact global markets, space mining operates in an interconnected global economy where information travels instantly and markets react within seconds. The moment NASA's Psyche mission confirms the asteroid's composition, or the first private mining mission returns samples to Earth, financial markets worldwide will immediately begin repricing every commodity, every mining company, every currency, and every investment that depends on resource scarcity assumptions. This market transformation could happen over days or weeks rather than years or decades. The speed of change could be unlike anything in economic history, creating both unprecedented opportunities and potentially catastrophic risks for those who aren't prepared. But beyond the economics and the technology, asteroid mining represents something even more profound. For the first time in human history, we're approaching the possibility of transcending the fundamental limitation that has shaped every civilization: the scarcity of the materials needed to build an advanced technological society. The implications of that transcendence extend far beyond anything we can currently imagine. We're not just talking about mining asteroids. We're talking about the next phase of human evolution, where our species moves beyond the constraints that have defined us since the dawn of civilization, and it's happening faster than anyone expected. The psychological impact of approaching post-scarcity conditions is already manifesting in unexpected ways across society. Financial advisors report increasing numbers of clients asking about abundance-proof investment strategies. Parents wonder how to teach their children about money and value when those concepts might become obsolete within their lifetime. Religious leaders grapple with theological questions about prosperity and suffering in a world where material want could disappear entirely. This anticipatory anxiety about abundance reveals something fundamental about human psychology. We're wired for scarcity. Our brains evolved to hoard resources, compete for limited goods, and find meaning through struggle against material constraints. The prospect of unlimited resources doesn't just challenge our economic systems. It challenges our understanding of what it means to be human. Consider how this plays out in everyday decision-making. When you choose between products based on price, you're engaging in scarcity-based thinking that has guided human behavior for thousands of years. When parents teach children to save money and avoid waste, they're passing down survival strategies that made sense in a resource-limited world. When societies organize around concepts of earning, deserving, and rationing, they're reflecting deep-seated assumptions about material limitations. Asteroid mining threatens to make all of these behaviors obsolete within a single generation. The implications ripple through every aspect of social organization. Educational systems built around preparing children for careers in resource-constrained industries might need complete restructuring. Legal frameworks based on property rights and resource ownership could require fundamental revision. Political systems organized around distributing limited resources might lose their primary function. The transition won't happen uniformly across all sectors or regions. Some industries will experience abundance cascades years before others. Electronics manufacturing could transform rapidly when rare earth elements become cheap, while industries dependent on biological resources might remain constrained by traditional limitations. This uneven transformation could create unprecedented economic distortions and social tensions. Early abundance adopters could gain enormous advantages over competitors still operating under scarcity assumptions. Companies that redesign their products and processes to take advantage of cheap advanced materials could dominate markets before traditional competitors understand what's happening. Nations that invest early in space mining capabilities could leapfrog ahead of countries still focused on terrestrial resource development. The geopolitical implications extend beyond simple resource competition. When traditional sources of national wealth become obsolete, global power structures could shift dramatically. Countries that currently derive influence from oil reserves, mineral deposits, or agricultural exports might find their strategic advantages evaporating. Meanwhile, nations that excel in space technology, robotics, and automated manufacturing could emerge as new superpowers. This power transition could happen with unprecedented speed. Unlike historical shifts that took decades or centuries to unfold, the abundance revolution could restructure global hierarchies within years of the first successful mining operations. The rapid pace of change could destabilize international relationships and create conflicts as traditional powers struggle to maintain influence in a transformed world. Military strategists are already wargaming scenarios where space-based resources create overwhelming technological advantages. Advanced materials could enable weapon systems, defensive technologies, and manufacturing capabilities that give early adopters decisive military superiority. The race for space resources could become the defining security challenge of the next century. But the military implications cut both ways. The same abundance that enables advanced weapons could also make conflict less likely by eliminating resource-based motivations for war. When energy and materials become plentiful, traditional causes of international tension might disappear. Wars over oil, water, and mineral rights could become obsolete when space-based alternatives provide unlimited supplies. The environmental transformation could be equally dramatic and complex. Eliminating Earth-based mining would remove one of the largest sources of ecological destruction on our planet. Entire ecosystems currently threatened by extraction industries could recover and flourish. The carbon footprint of materials production could plummet when manufacturing moves to space-based facilities powered by unlimited solar energy. However, the transition period could create its own environmental challenges. Rapid industrial changes could leave massive infrastructure stranded and potentially abandoned. Mining regions could face economic collapse that leads to environmental neglect. The social disruption could undermine support for environmental protection if communities prioritize economic survival over ecological concerns. Space-based manufacturing offers environmental benefits that extend beyond simply removing extraction from Earth. Products manufactured in zero gravity using unlimited energy could achieve performance characteristics impossible under terrestrial conditions. Materials science could advance rapidly when cost constraints disappear and experimentation becomes essentially free. These manufacturing advantages could enable environmental restoration technologies that are currently too expensive to deploy at scale. Advanced materials could make carbon capture systems economically viable for widespread deployment. Unlimited rare earth elements could enable massive renewable energy installations that completely replace fossil fuel systems. The circular economy could evolve in unexpected directions when raw materials become abundant. Instead of recycling driven by scarcity, product design could focus on optimal performance without material constraints. Goods could be built to last centuries rather than years, since replacement costs would be minimal. Alternatively, rapid prototyping and experimentation could become the norm when material waste carries no economic penalty. Consumer behavior could transform in ways that fundamentally alter market dynamics. When products contain materials worth more than their purchase price, traditional pricing models break down. When replacement parts cost more than entire new devices, repair economics become obsolete. When premium materials become common, luxury goods markets face complete restructuring. The luxury industry provides a fascinating case study in abundance adaptation. High-end brands currently derive value from scarcity and exclusivity. When rare materials become common, luxury companies must find new sources of differentiation. Craftsmanship, design, and brand heritage might become more important than material rarity. Some luxury brands are already preparing for this transition. Jewelry companies are investing in techniques for creating artificial scarcity through limited editions and artistic uniqueness. Fashion houses are exploring designs that emphasize creativity over material value. Watch manufacturers are developing movements that showcase mechanical complexity rather than precious metal content. The art market faces similar challenges and opportunities. When gold and platinum become as common as aluminum, traditional measures of artistic value might shift toward pure aesthetic and cultural significance. Artists could experiment with materials currently too expensive for creative use. Public art projects could incorporate advanced materials without concern for theft or vandalism. Educational systems worldwide are beginning to grapple with preparing students for abundance-based careers that don't currently exist. Traditional economics courses based on scarcity models might become obsolete. Engineering programs need to incorporate space-based manufacturing techniques. Business schools must develop frameworks for managing abundance rather than rationing scarcity. The most successful educational institutions might be those that focus on creativity, innovation, and social contribution rather than resource management skills. When material constraints disappear, human imagination and collaboration become the primary limiting factors in technological and social advancement. Research institutions face unprecedented opportunities when experimental costs become negligible. University laboratories could conduct materials research that currently requires million-dollar budgets. Students could experiment with techniques and materials that are currently accessible only to well-funded corporate research centers. The democratization of advanced research tools could accelerate scientific discovery in ways that traditional funding models never enabled. Breakthrough discoveries might emerge from unexpected sources when access to advanced materials and manufacturing capabilities becomes widespread. Medical research could advance particularly rapidly when cost constraints on experimental equipment and materials disappear. Personalized medicine could become practical when the rare earth elements needed for advanced diagnostic equipment become cheap and abundant. Gene therapy research could accelerate when specialized materials and manufacturing capabilities become widely accessible. The pharmaceutical industry could transform dramatically when the rare compounds needed for advanced drug manufacturing become economically viable. Medications that currently cost thousands of dollars per dose could become affordable for global distribution. Rare disease research could become economically attractive when material costs no longer limit experimental approaches. Healthcare delivery could change fundamentally when advanced medical devices become as affordable as basic equipment. Every community clinic could potentially access diagnostic and treatment capabilities that currently exist only in major medical centers. Global health equity could improve dramatically when technology costs no longer create barriers to advanced medical care. The biotechnology revolution could accelerate exponentially when the materials needed for genetic engineering and synthetic biology become abundant. Research that currently requires massive capital investments could become accessible to individual researchers and small organizations. The pace of biological discovery could increase dramatically when material constraints no longer limit experimentation. Agricultural technology could advance rapidly when the rare earth elements needed for precision farming equipment become cheap and widely available. Automated farming systems could become economically viable for small-scale operations. Food production could become more efficient and environmentally sustainable when advanced materials enable better growing systems and processing equipment. The food industry could transform in unexpected ways when packaging materials with advanced properties become economically viable. Food preservation could improve dramatically with packaging that actively maintains freshness and prevents spoilage. Distribution systems could become more efficient when lightweight, high-strength materials make transportation cheaper and more environmentally friendly. Urban planning could evolve dramatically when construction materials with unprecedented properties become affordable for widespread use. Buildings could incorporate materials that actively clean air, generate energy, and respond to environmental conditions. Infrastructure projects could use materials that last centuries while requiring minimal maintenance. Transportation systems could transform completely when advanced materials become cheap enough for widespread deployment. Roads could incorporate materials that generate electricity, communicate with vehicles, and repair themselves. Public transportation could become more efficient and comfortable when high-performance materials enable better vehicle designs. The aviation industry faces particularly dramatic transformation potential. Aircraft could incorporate materials that are currently too expensive for commercial use, enabling more efficient engines, lighter structures, and better performance characteristics. Space travel could become economically viable for ordinary consumers when spacecraft construction costs plummet due to abundant materials. Maritime transportation could benefit enormously from advanced materials that resist corrosion, reduce weight, and improve efficiency. Shipping costs could decrease dramatically when vessels can be built with materials that last longer and perform better than current alternatives. Ocean exploration could become more accessible when submarines and research vessels can be built with previously unaffordable materials. The entertainment industry could experience revolutionary changes when the materials needed for advanced display technologies, sound systems, and interactive experiences become economically accessible. Theme parks could incorporate technologies that are currently too expensive for widespread deployment. Home entertainment could reach levels of sophistication that currently exist only in professional installations. Sports equipment could evolve dramatically when high-performance materials become cheap enough for consumer products. Athletic performance could improve significantly when equipment optimization is no longer constrained by material costs. New sports and recreational activities could emerge when previously impossible equipment becomes economically viable. The implications for human performance enhancement extend beyond athletics into medical and technological augmentation. When the materials needed for advanced prosthetics, implants, and assistive technologies become abundant, the line between treatment and enhancement could blur significantly. Society might need to develop entirely new ethical frameworks for human modification in an age of material abundance. Space exploration could accelerate dramatically when the materials needed for spacecraft, habitats, and life support systems become cheap and abundant. Mars colonization could become economically viable when transportation and habitat construction costs plummet. The asteroid belt itself could become humanity's first truly self-sufficient space-based civilization. The long-term implications stretch far beyond our solar system. When materials become abundant enough to support massive construction projects, humanity could begin building generation ships capable of interstellar travel. Projects that currently exist only in science fiction could become engineering challenges rather than impossibilities. But perhaps the most profound change will be psychological and cultural. For the first time in human history, our species could transcend the material constraints that have shaped every previous civilization. The implications of that transcendence extend into philosophy, religion, art, and the fundamental meaning of human existence. When survival is guaranteed and material wants are satisfied, what drives human behavior? When competition for resources becomes obsolete, how do societies organize themselves? When work becomes optional rather than necessary, what gives life meaning and purpose? These questions don't have historical precedents because no previous civilization has faced genuine material abundance. The answers will determine whether asteroid mining becomes humanity's greatest achievement or creates challenges that threaten our social and psychological foundations. The transition could happen within the lifetime of people alive today. Children born in this decade might grow up in a world where material scarcity is a historical curiosity rather than a daily reality. Their relationship with consumption, waste, competition, and achievement could be fundamentally different from anything in human experience. Educational systems, parenting practices, and social institutions built around scarcity-based assumptions might need complete reconstruction to serve children growing up in abundance. The psychological and social adaptation could prove more challenging than the technological and economic transitions. But the opportunity is equally profound. Humanity could finally transcend the limitations that have constrained our species since the dawn of civilization. The creative and innovative potential unleashed by genuine material abundance could enable achievements that dwarf anything in our history. The race to asteroid mining isn't just about money or resources. It's about the next phase of human evolution, where our species moves beyond the constraints that have defined us and enters a new era of unlimited material possibility. The transformation is already beginning, accelerating with each technological breakthrough and each $1 billion invested in space mining ventures. The question isn't whether it will happen, but how quickly we can adapt to changes that will reshape every aspect of human civilization. And the clock is ticking faster than anyone expected. The race to Psyche isn't happening in isolation. While NASA's spacecraft travels through the void toward its metal-rich destination, private companies are already positioning themselves to capitalize on what could be the most profitable venture in human history, and the competition is getting fierce. SpaceX has quietly filed patents for asteroid capture and processing systems. Their Starship platform, originally designed for Mars missions, could easily be adapted for asteroid mining operations. With launch costs dropping to under $1,000 per kilogram, Elon Musk's company has created the economic foundation that makes space mining profitable. But they're not alone in this cosmic gold rush. Blue Origin, Jeff Bezos's space venture, has developed ion propulsion systems specifically designed for long-duration asteroid missions. Their New Shepard rockets are testing technologies that could enable robotic mining platforms to operate autonomously for years in the harsh environment of space. Bezos has publicly stated that he envisions millions of people living and working in space, supported by unlimited resources extracted from asteroids. But here's where the story takes an unexpected turn. The real game changers might not be the established space companies at all. Startup ventures with names like Planetary Resources, Deep Space Industries, and Asteroid Mining Corporation have raised billions in venture capital based on business plans that sound like science fiction but are grounded in solid engineering and economics. These companies aren't waiting for government missions to prove the concept. They're developing their own spacecraft, their own extraction technologies, and their own processing systems. Some have already launched test missions to nearby asteroids, gathering data that will inform full-scale mining operations within the next decade. The technology they're developing reads like a catalogue of futuristic engineering marvels. Autonomous robotic miners that can operate for years without human intervention. Solar-powered processing plants that can refine raw asteroid material into pure metals in the vacuum of space. Electromagnetic mass drivers that can launch processed materials toward Earth using nothing but solar energy. But perhaps the most ingenious innovation involves something called gravity tractors. These spacecraft would attach to asteroids and use their own gravity to slowly alter the space rock's orbit, gradually pulling it closer to Earth over several years. Instead of sending mining equipment to distant asteroids, this approach brings the asteroids to where processing facilities can access them more easily. The engineering challenges are immense, but so are the potential rewards. Early investors in successful asteroid mining ventures could see returns that make internet billionaires look poor by comparison. We're talking about investments that could multiply by factors of thousands rather than mere percentages. Consider this calculation that keeps venture capitalists awake at night. A single successful mining mission to a medium-sized metallic asteroid could return materials worth more than the gross domestic product of most countries. The initial investment might be $50 billion, but the return could be $50 trillion. Those aren't just good odds. Those are civilization-changing odds. The timeline for these private ventures is accelerating rapidly. What seemed impossible just 5 years ago now appears inevitable within the next 15 years. Advances in artificial intelligence have solved autonomous operation challenges. Improvements in solar panel efficiency have made space-based power systems viable. Breakthroughs in materials science have created equipment that can survive the extreme conditions of asteroid environments, but the most important factor might be the simplest one: money. The amount of capital flowing into space mining ventures has increased by 500% in the past 3 years. Pension funds, sovereign wealth funds, and ultra-high net worth individuals are placing massive bets on technologies that could reshape the global economy. This influx of capital is creating a positive feedback loop that accelerates development timelines. More money enables better technology, which attracts more investment, which funds even more ambitious projects. The space mining industry is experiencing the kind of exponential growth curve that characterized the early internet and smartphone revolutions. The competitive dynamics are fascinating to watch unfold. Traditional mining companies like Rio Tinto and BHP Billiton are partnering with space ventures to leverage their resource extraction expertise. Technology giants like Google and Microsoft are investing in space mining companies to secure future supplies of rare earth elements essential for their data centers and devices. Even more intriguingly, some of the world's wealthiest individuals are making personal investments that suggest they believe asteroid mining will succeed sooner rather than later. When people with access to the best information and analysis put their own money behind space mining ventures, it signals confidence that goes beyond speculative enthusiasm. The geopolitical implications are already creating international tensions that could reshape global alliances. China has announced a national asteroid mining program with funding that exceeds NASA's entire annual budget. Russia claims territorial rights over asteroids discovered by their spacecraft. The European Space Agency is developing independent capabilities to ensure European access to space-based resources. These competing national programs create risks and opportunities that extend far beyond economics. Countries that gain early access to asteroid resources could develop military and technological advantages that persist for generations. The nation that controls the first successful mining operation might dominate global politics for the next century. But the most fascinating aspect of this competition is how it could make traditional resource-based conflicts obsolete. When platinum becomes as common as aluminum, wars over mineral rights lose their economic motivation. When rare earth elements flow abundantly from space-based sources, competition for terrestrial deposits becomes pointless. This transition could happen faster than international relations can adapt. Diplomatic frameworks built around resource competition might become irrelevant before new cooperation models can develop. The speed of change could destabilize regions whose entire political structures depend on controlling scarce materials. The labor implications are equally complex and potentially disruptive. Asteroid mining operations will require entirely new types of expertise that don't currently exist in large numbers. Space-based engineers, zero-gravity manufacturing specialists, and autonomous systems operators will become some of the most valuable professionals in the global economy. Traditional mining jobs, however, could disappear almost entirely within a generation. Communities built around extraction industries might face economic collapse unless they successfully transition to post-mining economies. The social and political consequences could be severe in regions where mining provides the primary source of employment and government revenue, but the same technological advances that eliminate traditional mining jobs could create entirely new industries and employment opportunities. Space-based manufacturing, orbital construction, and interplanetary logistics could employ millions of people in careers that don't currently exist. The educational implications are staggering. Universities are already developing degree programs in space resource engineering, asteroid geology, and zero-gravity manufacturing. Students entering college today might graduate into careers that involve working in space-based facilities, processing materials from asteroids millions of miles away. The skills required for these careers blend traditional engineering with cutting-edge technologies in ways that challenge conventional educational categories. Space miners will need expertise in robotics, artificial intelligence, materials science, and autonomous systems operation. They'll also need to understand economics, environmental science, and international law as they apply to space-based operations. The insurance industry faces challenges that have no historical precedents. How do you ensure a mining operation worth trillions of dollars operating in the vacuum of space? What happens when equipment failures could strand valuable materials millions of miles from Earth? How do you assess risks for technologies that have never been tested at commercial scales? Lloyd's of London and other major insurers are developing entirely new risk assessment frameworks for space-based operations. The premiums for early asteroid mining missions could be enormous, but successful operations could generate profits large enough to make even high insurance costs economically viable. The banking sector is equally unprepared for the financial flows that successful asteroid mining could generate. When a single mining operation could generate more revenue than most countries produce annually, traditional banking infrastructure might be inadequate to handle the transactions. Central banks are quietly studying how asteroid mining wealth could affect monetary policy and currency stability. If a private company suddenly controls resources worth more than entire national economies, the balance of financial power could shift in ways that threaten governmental authority over monetary systems. The tax implications are particularly complex since current international law provides little guidance about taxing space-based economic activities. Should asteroid mining profits be taxed by the country where the company is incorporated, the country that launches the mission, or some new international framework designed specifically for space commerce? These regulatory uncertainties create risks for investors and potential barriers to development. Companies might delay major investments until legal frameworks become clearer. Alternatively, they might structure operations to take advantage of regulatory arbitrage, incorporating in countries with favorable space commerce laws. The environmental movement faces interesting dilemmas about how to respond to space mining. On one hand, asteroid mining could eliminate the need for environmentally destructive terrestrial extraction. On the other hand, the energy required for space missions and the potential for space debris creation raise new environmental concerns. Some environmental organizations are cautiously supporting asteroid mining as a way to reduce Earth-based ecological damage. Others worry that space mining could enable even higher levels of consumption and waste by removing resource constraints that currently limit environmental destruction. The religious implications are equally complex. Many faith traditions incorporate concepts of stewardship, moderation, and the spiritual value of material limitation. Post-scarcity abundance could challenge fundamental theological assumptions about the relationship between material and spiritual well-being. Some religious leaders are embracing asteroid mining as an opportunity to eliminate poverty and suffering caused by material want. Others worry that unlimited material wealth could lead to spiritual emptiness and loss of meaning that comes from struggle and sacrifice. The philosophical questions extend beyond religion into fundamental assumptions about human nature and social organization. Are competitive instincts and resource-focused behaviors essential aspects of human psychology, or are they adaptations to scarcity that could change when abundance becomes the norm? The answers to these questions will determine whether asteroid mining enables human flourishing or creates new forms of social and psychological dysfunction. The transition to post-scarcity conditions could require fundamental changes in how we think about work, achievement, and the meaning of a well-lived life. Cultural institutions, from museums to universities to artistic organizations, are beginning to grapple with how material abundance might affect human creativity and cultural development. When cost is no longer a constraint on artistic materials or scientific equipment, will creativity flourish, or will the absence of limitations paradoxically reduce innovation? The entertainment industry provides an interesting case study. Video game developers are already designing virtual worlds that assume unlimited access to advanced materials and manufacturing capabilities. These games might provide insights into how human behavior adapts to abundance conditions. Hollywood studios are developing movies and television shows that explore the social and psychological implications of post-scarcity abundance. Science fiction is becoming a laboratory for testing ideas about how human societies might function when material limitations disappear. The advertising industry faces fundamental challenges when traditional messages about scarcity, exclusivity, and material status become obsolete. How do you market products when the materials they're made from become essentially free? How do you create desire for goods when abundance eliminates the psychological appeal of possession? Some marketing experts predict that advertising will shift focus from material attributes to experiential and social benefits. Brand loyalty might become more important than product features when manufacturing costs become negligible. Companies might compete on design, service, and cultural association rather than price and material quality. The retail industry could transform completely when the cost of goods sold approaches zero for many products. Traditional pricing models break down when raw materials become essentially free. Profit margins could increase dramatically, but competition could also intensify when barriers to entry disappear. Manufacturing could become distributed and localized when advanced materials become cheap enough for small-scale operations. Instead of massive factories concentrating production in low-cost regions, every community could potentially produce most of the goods it needs using abundant space-derived materials and advanced fabrication technologies. This manufacturing revolution could reshape global trade patterns that have existed for centuries. Countries whose economies depend on exporting manufactured goods could lose their competitive advantages when production becomes economically viable everywhere. The logistics industry faces both opportunities and threats. While space-based resources could reduce the need to transport raw materials around the world, the distribution of finished goods might become more complex when manufacturing becomes widely distributed. Transportation systems could benefit enormously from advanced materials that become cheap through space mining. Vehicles could incorporate materials that are currently too expensive for widespread use, enabling more efficient engines, lighter structures, and better performance characteristics. The energy industry could experience the most dramatic transformation of all. When the rare earth elements needed for renewable energy systems become abundant, solar panels, wind turbines, and energy storage systems could become so inexpensive that fossil fuels become economically obsolete almost overnight. This energy revolution could solve climate change not through regulation and sacrifice, but through pure economic advantage. When clean energy becomes cheaper than dirty energy, The transition happens automatically through market forces rather than government intervention. The implications extend beyond Earth-based energy systems. Space-based solar power becomes economically viable when the materials needed for construction become cheap enough to justify massive orbital installations. These systems could provide unlimited clean energy for Earth while completely eliminating carbon emissions from power generation. Fusion power could finally become practical when the advanced materials needed for reactor construction become economically accessible. Research that has been constrained by material costs for decades could accelerate rapidly when experimentation becomes essentially free. The water industry could benefit from advanced materials that make desalination and purification systems more efficient and affordable. Global water scarcity could become a solved problem when the materials needed for advanced water treatment become widely available. Agriculture could transform through precision farming systems that use advanced sensors, automated equipment, and responsive growing environments. Food production could become more efficient and environmentally sustainable when the materials needed for advanced agricultural technology become cheap and abundant. The construction industry could experience a revolution similar to what happened when steel became cheap and abundant in the late 19th century. Buildings could incorporate materials with properties that far exceed anything currently economically viable. Infrastructure projects could use materials that last centuries while requiring minimal maintenance. Urban planning could evolve dramatically when construction materials with unprecedented properties become affordable for widespread use. Cities could incorporate materials that actively clean air, generate energy, and respond to environmental conditions. The implications cascade through every sector of human civilization. Healthcare, education, transportation, communication, entertainment, and governance could all transform in ways that are difficult to predict but certain to be profound. The timeline for these changes remains uncertain, but multiple indicators suggest the transformation could begin sooner than most people expect. Technological breakthroughs are accelerating. Investment capital is flowing rapidly into space mining ventures. Launch costs continue to plummet. Political and social pressure for alternatives to terrestrial mining is increasing. The convergence of these factors creates conditions that could enable rapid development of practical asteroid mining capabilities. The first successful operations could trigger cascade effects that transform global economics within years rather than decades. But perhaps the most remarkable aspect of this approaching revolution is how it could fundamentally alter humanity's relationship with the universe itself. For the first time in our species' history, we're approaching the ability to transcend the material limitations that have constrained every previous civilization. The implications of that transcendence extend far beyond economics or technology. We're potentially entering an era where human creativity and innovation are no longer limited by the availability or cost of raw materials. The only constraints on what we can build, create, or achieve might be the limits of our imagination and our ability to work together. The transformation won't be easy or automatic. The transition from scarcity-based to abundance-based economics will require fundamental changes in how we organize society, educate children, and think about value and meaning. But the potential rewards justify the challenges. We stand at the threshold of the most significant transformation in human history. The decisions we make in the next decade about how to develop and manage asteroid mining will determine whether this transformation becomes humanity's greatest achievement or creates challenges that threaten the foundations of civilization itself. The wealth floating in space represents more than just money. It represents the possibility of transcending limitations that have defined human experience since the dawn of our species. The question isn't whether we'll reach those resources, but whether we'll be wise enough to use them well, and that question will be answered sooner than anyone imagined possible. The social implications of asteroid mining wealth could prove even more transformative than the economic ones. For thousands of years, human societies have been organized around the fundamental assumption that resources are limited and must be carefully allocated. Our entire concept of fairness, justice, and social organization flows from this basic truth of scarcity. But what happens when that assumption becomes false? When the materials needed to build cities, manufacture goods, and power civilizations become essentially unlimited, the psychological and social adaptation required might be the greatest challenge our species has ever faced. Consider how this plays out in the most basic human relationships. Parents have always taught children to share because resources are limited. Competition for jobs exists because good positions are scarce. Social status often derives from controlling or accessing rare and valuable things. Marriage and family structures evolved partly to ensure resource sharing and security in an uncertain world. When material abundance eliminates these constraints, the fundamental drivers of human behavior could change in ways we can barely comprehend. Children might grow up never experiencing true scarcity, developing psychological profiles completely unlike any previous generation. Social hierarchies based on wealth accumulation could collapse when anyone can access unlimited materials. The concept of ownership itself becomes problematic in a post-scarcity world. Property rights exist because things are limited and valuable. When advanced materials become as common as air, traditional legal frameworks around possession and control lose their meaning. Entire areas of law, from property disputes to inheritance rights, might become obsolete. Work represents another fundamental challenge. Throughout human history, most people have worked because they needed resources to survive. They traded their time and effort for money that could be exchanged for food, shelter, and other necessities. When those necessities become freely available through abundant materials and automated production, the basic motivation for employment disappears. Some economists predict this could enable a golden age of human creativity, where people pursue meaningful activities rather than survival-focused jobs. Others warn it could lead to widespread purposelessness and social dysfunction when traditional sources of meaning and achievement vanish. The transition period could be particularly chaotic as different sectors of the economy transform at different rates. Some industries might experience abundance cascades years before others, creating unprecedented economic distortions. Workers in traditional mining and manufacturing could lose their jobs, while new space-based industries struggle to find qualified personnel. Educational systems face the challenge of preparing students for careers that don't currently exist, while traditional subjects become obsolete. How do you teach economics when scarcity-based models no longer apply? How do you prepare young people for a world where the skills valued by previous generations become irrelevant? The speed of change could outpace humanity's ability to adapt socially and psychologically. Unlike previous technological revolutions that unfolded over generations, asteroid mining could transform civilization within a single decade. The social institutions, cultural practices, and psychological frameworks that help societies manage change might prove inadequate for the magnitude and pace of transformation ahead. Religious and philosophical systems could face existential challenges when core assumptions about suffering, sacrifice, and the spiritual value of material limitation become obsolete. Many faith traditions teach that struggle and want serve important purposes in human development. Post-scarcity abundance could undermine these teachings in ways that threaten the foundations of meaning and purpose that have sustained civilizations for millennia. The criminal justice system represents another institution that could require complete reconstruction. Many crimes are motivated by resource scarcity. Theft, fraud, and economic crimes lose their logic when valuable materials become freely available. Prisons designed around punishment and resource denial might need fundamental reconceptualization when material deprivation becomes impossible. International relations could transform completely when traditional sources of conflict disappear. Wars over oil, water, minerals, and arable land become pointless when space-based alternatives provide unlimited supplies. The entire framework of international law, trade agreements, and diplomatic relationships might require rebuilding from scratch. Currency systems face particular challenges when the materials that have traditionally backed money become worthless through abundance. Gold and silver standards become meaningless when these metals can be extracted from space in unlimited quantities. Even modern fiat currencies could lose credibility when the economic assumptions underlying monetary policy collapse. Central banks worldwide are quietly studying these implications, but their solutions remain theoretical. No economic institution has ever managed the transition from scarcity-based to abundance-based systems. The Federal Reserve, European Central Bank, and other monetary authorities might find their traditional tools completely inadequate for managing abundance-driven economic changes. The insurance industry faces similar challenges with no historical precedents. How do you assess risk when fundamental assumptions about value and scarcity no longer apply? What happens to insurance markets when the materials being insured become essentially worthless through abundance? Healthcare systems could benefit enormously from abundant advanced materials, but the transition could create its own challenges. When medical devices become essentially free to manufacture, healthcare delivery models based on equipment costs become obsolete. Medical schools might need complete curriculum overhauls to prepare doctors for practice in abundance-based healthcare systems. The pharmaceutical industry could experience revolutionary changes when rare compounds needed for advanced medications become economically viable for mass production. Personalized medicine could become standard practice when cost is no longer a limiting factor in treatment approaches. Mental health professionals anticipate unprecedented challenges as societies adapt to post-scarcity conditions. Depression, anxiety, and other psychological disorders could manifest in entirely new ways when traditional sources of stress disappear, but new forms of existential uncertainty emerge. The entertainment industry provides an interesting preview of how human creativity might evolve under abundance conditions. Video games already create virtual worlds where resources are unlimited, and players often struggle with motivation and purpose when traditional survival challenges disappear. These digital experiments might offer insights into how real-world abundance could affect human psychology. Sports and competitive activities could become more important when material competition becomes meaningless. Athletic achievement, artistic creation, and intellectual accomplishment might become the primary ways individuals distinguish themselves when material accumulation no longer serves that function. The art world faces fascinating questions about value and meaning when precious materials become common. Will paintings created with rare pigments lose their appeal when those pigments become freely available? Will sculpture incorporating expensive metals become less valuable when the materials cost nothing? Some art critics predict a renaissance of creativity when artists gain access to materials currently too expensive for experimentation. Others worry that removing material constraints could paradoxically limit artistic innovation by eliminating the creative tension that comes from working within limitations. Fashion industries could transform dramatically when advanced materials with unprecedented properties become available for clothing and accessory design. Luxury brands built around rare materials might lose their exclusivity, but new forms of distinction based on design, craftsmanship, and cultural significance could emerge. The travel industry could benefit enormously from lightweight, high-strength materials that make transportation more efficient and affordable. Space tourism could become accessible to ordinary consumers when spacecraft construction costs plummet due to abundant materials. Architecture could experience a revolution when building materials with extraordinary properties become economically viable for widespread use. Structures could incorporate materials that actively respond to environmental conditions, generate energy, and maintain themselves automatically. Urban planning could evolve to take advantage of materials that make previously impossible infrastructure projects economically feasible. Cities could incorporate systems that actively clean air and water, generate renewable energy, and adapt to changing conditions. Transportation systems could transform when vehicles can incorporate materials currently too expensive for consumer applications. Personal transportation could become more efficient, safer, and more environmentally friendly when advanced materials enable better design and performance. The implications extend beyond Earth-based applications into space exploration and colonization. When the materials needed for spacecraft, habitats, and life support systems become abundant, human expansion throughout the solar system becomes economically viable. Mars colonization could accelerate rapidly when transportation and habitat construction costs plummet through abundant space-derived materials. The asteroid belt itself could become humanity's first truly self-sufficient space-based civilization, mining resources to support further expansion throughout the solar system. Interstellar exploration could become possible when materials become abundant enough to support massive construction projects like generation ships. Technologies currently relegated to science fiction could become engineering challenges rather than impossibilities. But the most profound implications might be psychological and cultural. Human beings evolved in environments of scarcity, and our deepest instincts and behaviors reflect adaptations to resource limitations. The transition to genuine abundance could require psychological evolution that challenges the fundamental nature of human experience. Children growing up during this transition might develop completely different relationships with competition, sharing, and achievement. Their values, motivations, and life goals could be unlike anything in previous human experience. The generational divide between scarcity-adapted and abundance-adapted humans could create social tensions unlike any in history. Language itself might require evolution to accommodate concepts and experiences that don't exist in scarcity-based societies. New words and expressions might emerge to describe abundance-related phenomena, while traditional terms related to want and limitation could become obsolete. Cultural practices around conservation, thrift, and resource management could disappear within a generation. Traditions that served important survival functions in resource-limited societies might lose their relevance entirely. The cultural wisdom accumulated over thousands of years of scarcity-based existence could become as obsolete as Stone Age toolmaking techniques. Yet this transformation could also unlock human potential in ways we can barely imagine. When survival needs are guaranteed and material wants are satisfied, human creativity and innovation could flourish without the constraints that have limited previous generations. Scientific research could accelerate dramatically when experimental costs become negligible. Artistic expression could reach new heights when creators have access to any materials they can imagine. Social cooperation could improve when resource competition disappears as a source of conflict. The transition won't happen overnight, but it could unfold faster than most people expect. The technological and economic foundations are already being laid. Private companies are raising billions to develop asteroid mining capabilities. Launch costs continue to plummet. Robotic and artificial intelligence technologies are solving the challenges that make space-based operations feasible. NASA's Psyche mission will provide crucial data that could accelerate private investment and development timelines. If the spacecraft confirms that the asteroid contains the predicted concentrations of valuable metals, financial markets could begin pricing in abundance conditions years before actual mining operations begin. The competitive dynamics are intensifying as more players enter the space mining race. Countries and companies that gain early advantages could dominate the transformation, potentially creating new forms of inequality even as traditional resource-based disparities disappear. The regulatory framework remains unclear, creating risks and opportunities for early movers. International law provides little guidance for managing space-based resource extraction or distributing abundance-derived wealth. The legal vacuum could lead to conflicts or could enable rapid development by removing regulatory barriers. Environmental considerations add another layer of complexity. While space mining could eliminate terrestrial environmental damage from extraction industries, the energy required for space operations and the potential for space debris creation raise new ecological concerns. The social and political implications could prove more challenging than the technological ones. Managing the transition from scarcity-based to abundance-based economics will require unprecedented cooperation and planning. The decisions made during this transformation could determine whether abundance becomes humanity's greatest opportunity or its greatest challenge. What's becoming clear is that asteroid mining represents more than just a new industry or investment opportunity. It's the beginning of a transformation that could reshape human civilization itself. The wealth floating in space could solve problems that have plagued our species for millennia, but it could also create new challenges we've never faced. The race to capture that wealth is accelerating, driven by technological advances, increasing investment, and growing recognition of the stakes involved. The first successful asteroid mining operation won't just create unprecedented profits, it will trigger cascading changes that transform every aspect of human society. The timeline remains uncertain, but the momentum is building. Within the next 2 decades, we could witness the beginning of the most significant transformation in human history. The age of scarcity that has defined every previous civilization could finally come to an end. But ending scarcity is just the beginning. Learning to live with abundance might prove to be humanity's greatest challenge yet. The decisions we make about how to develop, regulate, and distribute asteroid mining wealth will determine whether this transformation becomes our species' greatest achievement or creates problems we're not prepared to handle. The countdown to the abundance revolution has already begun. The question isn't whether it will happen, but whether we'll be ready when it does. The psychological transformation could happen faster than anyone anticipates. Right now, financial advisors are fielding calls from clients asking how to protect their portfolios against abundance. Parents are questioning whether they should still teach their children about saving money. Investment managers are developing algorithms to trade on scarcity collapse scenarios. This isn't theoretical anymore. The markets are already beginning to price in a future that most people can't even imagine. Platinum futures show volatility patterns that suggest institutional traders are hedging against supply disruption from space. Mining company stocks experience wild swings whenever asteroid mining makes headlines. Currency markets fluctuate as investors question which assets will retain value in a post-scarcity world. The speed of this psychological shift reveals something crucial about human nature. We don't need to experience abundance directly to begin adapting to it. The mere possibility of unlimited resources starts changing behavior immediately. Young investors are avoiding traditional mining stocks. Tech companies are redesigning products assuming cheap rare earth elements. Nations are quietly restructuring their economic strategies around space-based resource scenarios. But here's where the transformation takes an even more dramatic turn. The abundance revolution won't just change how we think about materials and money. It will fundamentally alter what it means to be human in ways that challenge our deepest assumptions about consciousness, purpose, and existence itself. Consider what happens when the primary driver of human behavior for thousands of years suddenly disappears. The need to compete for limited resources has shaped our evolution, our psychology, our social structures, and our individual motivations. Remove that pressure, and you're conducting the largest psychological experiment in human history. Children born during the abundance transition might develop cognitive patterns unlike any previous generation. Their brains could literally wire differently when scarcity-based thinking becomes obsolete. These abundance natives might think about sharing, competition, and achievement in ways that are completely alien to scarcity-adapted adults. The generational divide could be more extreme than any in human history. Imagine trying to explain concepts like saving money or rationing resources to someone who grew up with unlimited access to advanced materials. The cultural gap might be unbridgeable, creating social tensions that make current generational conflicts seem trivial. Educational institutions are scrambling to adapt, but they're operating blind. How do you prepare students for careers that don't exist yet in an economy based on principles that haven't been tested? Traditional subjects like economics become obsolete when scarcity models no longer apply. New fields emerge around abundance management, post-scarcity sociology, and infinite resource optimization. The timeline compression is accelerating every month. What seemed like science fiction concepts just 5 years ago are now serious investment opportunities attracting billions in venture capital. The technological barriers that once made asteroid mining impossible are falling faster than anyone predicted. Artificial intelligence advances have solved autonomous operation challenges that stumped engineers for decades. Robotic systems can now perform complex manufacturing and repair operations in space environments without human oversight. Machine learning algorithms adapt to unexpected conditions and optimize operations in real time. Propulsion technology has reached breakthrough levels that make asteroid missions economically viable. Ion drives powered by massive solar arrays can accelerate spacecraft to velocities that reduce travel times from decades to years. Nuclear propulsion systems under development could cut those times to months. But the most important breakthrough might be the simplest one. Launch costs have dropped so dramatically that space operations are entering the realm of economic feasibility for private companies. When SpaceX demonstrated that rockets could be reused like airplanes, they didn't just reduce costs, they opened the door to an entirely new economic model for space commerce. This cost reduction creates positive feedback loops that accelerate development timelines. Cheaper launches enable more missions. More missions generate more data and experience. Better data and experience lead to improved technology and further cost reductions. The cycle continues until space operations become as routine as international shipping. Private companies are no longer waiting for government approval or funding. They're raising capital independently and developing technologies on compressed timelines that would be impossible within traditional aerospace bureaucracies. Some startups are promising asteroid mining operations within 15 years using technologies that exist today. The competitive pressure is intense. Companies know that first-mover advantages in asteroid mining could be worth trillions of dollars and decades of market dominance. This creates incentives for risk-taking and rapid development that push the boundaries of what's technically possible. International competition adds another layer of urgency. Countries that fall behind in space mining capabilities could find themselves economically irrelevant when abundance transforms global markets. National security concerns are driving government investment and regulatory support that accelerates private development. China has announced asteroid mining programs with funding that dwarfs most national space budgets. Russia is developing technologies specifically designed for space resource extraction. The European Space Agency is coordinating multinational efforts to ensure European access to space-based wealth. This international race creates geopolitical tensions that could reshape global alliances. Traditional resource-based relationships between nations become obsolete when space mining provides unlimited alternatives. Countries that currently derive power from oil reserves or mineral deposits might find their influence evaporating overnight, but the same forces that eliminate traditional power structures could create entirely new forms of international cooperation. When resource scarcity no longer drives conflict, nations might find reasons to work together on projects that benefit all humanity. Space mining operations could become collaborative ventures that unite countries around shared abundance rather than dividing them through competition for limited resources. The environmental implications extend far beyond simply reducing terrestrial mining damage. Space-based manufacturing powered by unlimited solar energy could produce goods with essentially zero environmental impact. The carbon footprint of materials production could disappear when processing moves to space-based facilities. Advanced materials enabled by abundant rare earth elements could revolutionize environmental restoration technologies. Carbon capture systems could become economically viable for global deployment. Renewable energy installations could replace fossil fuel systems entirely through pure economic advantage rather than regulatory mandate. Ocean cleaning operations could deploy technologies that are currently too expensive for large-scale implementation. Atmospheric engineering projects could become feasible when material costs no longer limit experimental approaches. Ecosystem restoration could accelerate when the tools needed for environmental repair become widely accessible. The circular economy could evolve in unexpected directions when raw materials become essentially free. Instead of recycling driven by scarcity, product design could optimize for performance and durability without material constraints. Goods could be built to last centuries since replacement costs would be minimal. Alternatively, rapid prototyping and experimentation could become standard practice when material waste carries no economic penalty. Innovation cycles could accelerate when failure costs disappear and unlimited resources enable constant iteration and improvement. Consumer psychology faces fundamental challenges when traditional value signals become meaningless. Luxury goods markets built around material rarity could collapse overnight. Premium products differentiated by expensive components might lose their appeal when those materials become common. But new forms of value creation could emerge based on design excellence, craftsmanship quality, and cultural significance rather than material scarcity. Brands might compete on creativity and innovation rather than exclusivity and price. Customer relationships could become more important than product features when manufacturing costs approach zero. The advertising industry confronts existential questions about how to create desire when abundance eliminates the psychological appeal of possession. Marketing messages based on scarcity, exclusivity, and status competition become obsolete when everyone can access advanced materials and products. Some experts predict advertising will shift toward experiential and social benefits rather than material attributes. Community building and cultural association might become more valuable than product ownership. Services and experiences could replace goods as the primary focus of consumer spending. Retail systems could transform completely when cost of goods sold approaches zero for many products. Traditional pricing models break down when raw materials become essentially free. Competition might intensify when barriers to entry disappear, but profit margins could increase dramatically for successful brands. Manufacturing could become distributed and localized when advanced materials become cheap enough for small-scale operations. Every community could potentially produce most goods locally using abundant space-derived materials and advanced fabrication technologies. Global supply chains built around low-cost production centers might become obsolete. This manufacturing revolution could reshape international trade patterns that have persisted for centuries. Countries whose economies depend on exporting manufactured goods could lose competitive advantages when production becomes economically viable everywhere. New forms of economic specialization might emerge based on creativity and innovation rather than cost advantages. The implications cascade through every aspect of human civilization at speeds that challenge our ability to adapt. But perhaps the most profound change involves something even more fundamental than economics or technology. The transformation could alter humanity's relationship with the universe itself in ways that redefine what it means to be conscious beings in an infinite cosmos. For the first time in our species' existence, we're approaching the ability to transcend material limitations that have constrained every previous generation. The creative potential unleashed when resources become unlimited could enable achievements that dwarf anything in human history. Scientific research could accelerate exponentially when experimental costs become negligible. Artistic expression could reach unprecedented heights when creators access any materials imaginable. Social cooperation could improve when resource competition disappears as a source of conflict. The space exploration implications extend beyond our solar system into possibilities that currently exist only in imagination. Generation ships capable of interstellar travel become engineering challenges rather than impossibilities when materials for massive construction projects become abundant. Dyson spheres and other megastructures that could harness the entire energy output of stars become feasible when unlimited resources eliminate construction constraints. Humanity could begin projects that span thousands of years and encompass entire stellar systems. But the most remarkable aspect of this transformation is how it could happen within the lifetime of people alive today. Children born in this decade might grow up in a world where material scarcity is a historical curiosity rather than a daily reality. Their relationship with consumption, competition, and achievement could be fundamentally different from anything in human experience. The transition won't be smooth or automatic. Managing the shift from scarcity-based to abundance-based economics will require unprecedented cooperation and wisdom. The decisions made during this transformation will determine whether abundance becomes humanity's greatest opportunity or creates challenges that threaten civilization itself. Social institutions built around resource allocation and scarcity management might require complete reconstruction. Legal frameworks based on property rights and ownership could become obsolete when valuable materials are freely available. Political systems organized around distributing limited resources might lose their primary function. Religious and philosophical traditions face profound challenges when core teachings about suffering, sacrifice, and material limitation encounter post-scarcity reality. New frameworks for meaning and purpose might need to emerge when traditional sources of motivation and achievement become irrelevant. The psychological adaptation could prove more difficult than the technological or economic transitions. Human beings evolved in environments of scarcity, and our deepest instincts reflect those evolutionary pressures. Learning to function in genuine abundance might require psychological evolution that challenges fundamental aspects of human nature, yet the potential rewards justify the challenges. Humanity could finally transcend limitations that have defined our existence since the dawn of consciousness. The creative and innovative potential unleashed by unlimited resources could enable achievements beyond current imagination. The race to capture that potential is accelerating with each technological breakthrough and each $1 billion invested in space mining ventures. Multiple indicators suggest the transformation could begin sooner than most people expect. The convergence of advancing technology, falling costs, and increasing investment creates conditions that could enable practical asteroid mining within decades rather than centuries. NASA's Psyche mission represents just the beginning of humanity's expansion into space-based resource extraction. The data collected from that metallic world will inform private mining ventures already raising capital for operations that could begin before 2040. The implications stretch across every aspect of human civilization. Healthcare systems could benefit from unlimited access to rare materials needed for advanced medical devices. Educational institutions could provide every student with laboratory equipment that currently exists only in major research facilities. Transportation systems could incorporate materials that enable unprecedented efficiency and performance. Energy systems could transform when the rare earth elements needed for renewable technologies become abundant through space mining. Climate change could be solved not through sacrifice and regulation, but through economic advantages that make clean energy cheaper than fossil fuels. The environmental benefits extend beyond energy into materials production, manufacturing processes, and waste management systems. Space-based operations could eliminate terrestrial environmental damage while providing unlimited resources for restoration and improvement projects. But perhaps the most important implication involves humanity's expansion beyond Earth itself. When materials become abundant enough to support massive space-based construction projects, our species could establish self-sufficient civilizations throughout the solar system and eventually beyond. The asteroid belt could become humanity's first truly independent space-based society, mining resources to support further expansion and development. Mars colonization could accelerate when transportation and habitat construction costs plummet through abundant materials. Interstellar exploration could transition from science fiction to engineering challenge when unlimited resources enable construction of generation ships and other technologies needed for travel between star systems. The timeline for these developments depends on decisions made in the next few years about investment priorities, regulatory frameworks, and international cooperation. The choices we make about how to develop asteroid mining will determine whether this transformation becomes humanity's greatest achievement or creates problems we're unprepared to handle. What's becoming clear is that the age of asteroid mining is approaching rapidly, and its effects will be felt by every person on Earth. The wealth floating in space represents more than money. It represents the possibility of transcending scarcity itself and entering a new phase of human evolution where material limitations no longer constrain our potential. The countdown has begun. The question isn't whether asteroid mining will transform civilization, but whether we'll be wise enough to manage that transformation successfully. The decisions made in the next decade could determine the trajectory of human development for centuries to come, and time is running out faster than anyone expected. The transformation is happening now, whether we're ready or not. While you've been reading this, SpaceX has conducted another successful Starship test. Private mining companies have secured another $1 billion in funding. NASA's Psyche spacecraft has traveled thousands of miles closer to its metallic destination, and somewhere in a boardroom, investors are making decisions that will reshape human civilization. The psychological shift is already underway in ways most people don't recognize. Children today are growing up in a world where space mining isn't science fiction, but inevitable reality. They're developing different relationships with scarcity, different assumptions about what's possible, different expectations about the future. These abundance natives might be the first generation in human history to experience genuine material freedom. But here's what keeps economists awake at night. The transformation could happen so quickly that our social and economic systems simply can't adapt in time. Markets that took centuries to develop could collapse in months. Currencies backed by precious metals could become worthless overnight. Entire nations whose economies depend on resource exports could face complete economic collapse before they can transition to new models. The speed of change represents both the greatest opportunity and the greatest risk in human history. Countries and companies that position themselves correctly could dominate the global economy for generations. Those that fail to adapt could find themselves irrelevant in a world where their primary sources of wealth and power have evaporated. The financial markets are already beginning this adaptation. Hedge funds are developing trading algorithms specifically designed to profit from commodity price collapses. Pension funds are quietly shifting investments away from traditional resource companies. Central banks are studying monetary policy frameworks that could function in post-scarcity economies. Yet most people remain completely unaware of what's coming. They're planning careers in industries that might not exist in 20 years. They're making investment decisions based on scarcity assumptions that could prove catastrophically wrong. They're raising children for a world that might bear no resemblance to the one we know today. The education system faces perhaps the greatest challenge of all. How do you prepare students for careers that don't exist in an economy based on principles that have never been tested? Traditional subjects become obsolete when scarcity-based models no longer apply. New fields emerge around abundance management that require entirely different ways of thinking about value, distribution, and human motivation. Some universities are already developing degree programs in space resource engineering and post-scarcity economics. Students are learning about autonomous mining systems, zero-gravity manufacturing, and abundance-based social organization. These pioneers might become the architects of humanity's post-scarcity future. But the most profound changes will be psychological and cultural. When the fundamental driver of human behavior for thousands of years suddenly disappears, everything we think we know about human nature gets called into question. Will people still work when survival is guaranteed? Will they still compete when resources are unlimited? Will they still find meaning and purpose when traditional achievements become effortless? The answers to these questions will determine whether asteroid mining becomes humanity's greatest triumph or its greatest tragedy. Unlimited resources could unlock human potential in ways we can barely imagine, enabling creativity, innovation, and cooperation on unprecedented scales, or they could lead to purposelessness, social collapse, and psychological dysfunction on a species-wide level. What we do know is that the transformation is accelerating. Every technological breakthrough, every successful rocket launch, every $1 billion invested in space mining brings us closer to a future that will reshape everything we understand about economics, society, and human existence itself. The race to Psyche isn't just about mining a metallic asteroid. It's about determining whether humanity can successfully navigate the transition from scarcity to abundance, from limitation to unlimited possibility, from our current civilization to something entirely new. The stakes couldn't be higher because this transformation will happen exactly once in human history. There are no do-overs, no second chances to get this right. The generation alive today will make decisions that echo through every future generation of our species. Children born after successful asteroid mining begins will inhabit a fundamentally different universe than the one we know. Think about what that means for a moment. Every human who has ever lived, from the first cave painters to Einstein to your own grandparents, lived under the same basic constraint. Resources were limited, materials were scarce, progress required struggle against the fundamental physics of shortage. But the children of the abundance age will know none of this. They'll grow up in a world where the question isn't whether something can be built, but whether it should be built. The psychological implications are staggering. Imagine trying to explain the concept of poverty to someone who has never seen want. Imagine describing economic inequality to people who grew up with unlimited access to advanced materials. These abundance natives won't just think differently about money and resources. They'll think differently about competition, cooperation, achievement, and the very meaning of success. But here's where the story takes its most dramatic turn. The abundance revolution isn't waiting for us to figure out the social implications. It's accelerating whether we're ready or not. Private companies are already testing asteroid capture technologies. Robotic mining platforms are being designed and built in facilities across the globe. The first generation of space miners are learning their trade in simulators that recreate the exact conditions they'll face on metallic asteroids. The timeline has compressed beyond anything experts predicted just 5 years ago. What seemed like distant future possibilities are now engineering challenges with projected completion dates. Venture capitalists who once dismissed space mining as fantasy are writing checks for hundreds of millions of dollars. Insurance companies are developing policies for asteroid mining operations. International lawyers are drafting frameworks for space-based resource rights. Most remarkably, the transformation is already changing behavior here on Earth. Young entrepreneurs are building companies designed to thrive in post-scarcity markets. Architects are designing buildings that assume unlimited access to advanced materials. Engineers are developing technologies that only make economic sense when rare earth elements become cheap and abundant. The financial world is quietly preparing for the biggest disruption in economic history. When the first asteroid mining operation succeeds, every assumption about value, scarcity, and wealth will need immediate revision. Stock markets could swing by percentages that have never been recorded. Commodity prices could collapse so quickly that trading systems struggle to keep up. Currency values could fluctuate wildly as investors try to determine which assets will retain meaning in an abundance-based economy. Central banks are studying scenarios that read like science fiction, but represent their most likely future challenges. How do you conduct monetary policy when the materials backing currency become essentially worthless? How do you manage inflation when production costs approach zero for most manufactured goods? How do you maintain economic stability when the fundamental assumptions underlying capitalism suddenly become obsolete? These aren't theoretical questions anymore. They're practical challenges that monetary authorities will face within the next 2 decades. The Federal Reserve, European Central Bank, and other institutions built around managing scarcity-based economies might find their traditional tools completely inadequate for abundance-driven conditions. Yet the opportunities are equally unprecedented. When materials become unlimited, human creativity becomes the only constraint on technological advancement. Scientists could test thousands of experimental approaches without worrying about wasting expensive resources. Engineers could iterate through countless design variations to achieve perfect optimization. Artists could work with materials currently reserved for specialized applications. The innovation acceleration could be extraordinary. Technologies that currently exist only as theoretical possibilities could become practical realities within years. Fusion reactors could use materials that are currently too expensive for large-scale construction. Quantum computers could incorporate components that cost thousands of times less than today. Medical devices could utilize rare elements that transform from luxury items to standard equipment. But perhaps most importantly, asteroid mining could solve humanity's greatest existential challenge. Climate change, resource depletion, and environmental destruction all stem from the same root cause: our need to extract materials from Earth's finite ecosystems. When space provides unlimited alternatives, the pressure on terrestrial environments could disappear entirely. Imagine a world where every mine closes because space-based alternatives provide better materials at lower costs, where every oil well becomes obsolete because abundant rare earth elements make renewable energy systems cheaper than fossil fuels, where every forest threatened by resource extraction becomes protected simply because the economic incentive for destruction vanishes. This environmental restoration could happen automatically through market forces rather than regulation. When space-based materials become cheaper than terrestrial alternatives, companies will choose abundance over destruction purely for economic reasons. The transition to sustainable practices becomes inevitable rather than aspirational. The timeline for this transformation depends partly on factors beyond human control. Solar activity, asteroid orbits, and technological reliability all influence when space mining becomes practical. But the human factors might be more important. Political decisions, investment priorities, and international cooperation will determine how quickly the abundance revolution unfolds. Early movers could gain advantages that persist for generations. Countries that invest heavily in space mining capabilities now could dominate global economics for the next century. Companies that position themselves correctly could become the first trillion-dollar enterprises in human history. Individuals who understand the implications could build wealth that survives the transition from scarcity to abundance, but the greatest rewards might go to those who solve the social and psychological challenges of post-scarcity living. The technologies needed for asteroid mining are advancing rapidly. The social frameworks needed for abundance-based civilization remain largely theoretical. Whoever figures out how to organize human societies around unlimited resources rather than scarcity competition could shape the future of our species. The transformation has already begun in ways that most people don't recognize. The children growing up today will live through changes that dwarf any previous human experience. They'll witness the end of resource-based economics and the beginning of something entirely new. They'll inherit a world where the primary challenges are philosophical and creative rather than material and survival-focused. The wealth floating in space represents more than the greatest treasure in human history. It represents the key to unlocking human potential from constraints that have limited our species since consciousness first emerged. The question isn't whether we'll reach those resources. The question is whether we'll be wise enough to use them to create a civilization worthy of such unprecedented abundance. That question will be answered sooner than anyone realizes, and the answer will determine everything that comes after.